Hello, dear colleagues. Today I'm gonna be presenting in Russian. My name is Anastasiya. I'm Senior Fellow on Communications with RIPE NCC, and this is the work of my colleagues from the Research Department. And last year was delivered by my colleague Kasim Long. So I would like to ask you, those who had been at the previous CAPIF, please raise your hands. Not so many of you, but maybe some of this information might be familiar to you because already gave you this presentation last year. But anyways, I'd like to go through what we're going to talk about: the development of internet technologies in Central Asia, implementation of RPKI and IPv6 in the region. Let's start with the point that we need to talk about the internet resources in the region. We're going to talk about some percentages, ratios, the level of implementation of IPv6 percentage-wise. But this is always a percentage of IP addresses that are registered in a particular country. So if you take a look at the region of Central Asia, you can see that there is a variable number of resources available in different countries. Kazakhstan is in the lead. The number of RIPE NCC members in Kazakhstan and the number of autonomous system in Kazakhstan great. In Uzbekistan, lots of population, but fewer IPv4 addresses. So the reason I'm going to tell you about this when we talk about percentages, please don't compare. Please keep in mind that here we're talking about different numbers. Iran. We showed this separately on a separate page because if it were together, we wouldn't be able to see anything about Central Asia because in Iran, there is a highly diversified internet ecosystem, lots of RIPE NCC participants, lots of autonomous systems. Now we move to our statistics, speak about the security internet and security of routing in the internet. We know because here we have the audience who is quite familiar with BGP. This is the main routing protocol. And luckily, BGP was designed based on trust. And security wasn't one of the main elements of this protocol's design. But in our closely interrelated world, the routing security is the foundation for stable internet, reliable internet. But unfortunately, we do have some incidents and key instances with BGP when we risk some security of the internet. For instance, an operator by mistake can redirect traffic, or someone can willfully do this and cause any disruptions in the internet. One of the examples could be the example of 2008 when Pakistan Telecom, they caught the global YouTube IP addresses, and this caused the global failure in the network. So this incident showed how minor error can have global consequences for our interconnect. And then this new technology appeared, RPKI. I think many of you are familiar with this. It was created specifically to prevent from such accidents happening and help minimize any accidental, intentional BGP errors. RPKI helps to respond to this question. Is the autonomous system authorized to announce this prefix? So in order to effectively implement RPKI, there are like two steps. Number one, to cover your addresses, route origin authorization, ROA, maybe I misinterpret So because I know these terms in English and I get this translated into Russian, please correct me. We use this row in order to protect your autonomous systems and tell which of these are authorized to announce specific prefixes. Number two, ROV. This is one ROV, when the validation of the source of routing happens. This is the BGP specific. So here, the colleague Jim Cowie, who presented yesterday, he gave me some good analogy that may help RPKI. This is like a system of the border control. If RO is your passport that identifies your personality, ROE, this is when you go through the passport control, border control, and they check your identity. The passport identifies your personality. If no one defines that, you can walk around without any problems. Next slide. Again, this is one of the incidents last year. Kasim talked about this. There is one link. One of those cases after RPKI, the effort by the government of Iraq to block Telegram and Cloudflare 1.1.1.1. Well, compared to what Pakistan Telecom did, it wasn't a global failure because of the RPKI technology available. And then we move to the practical things. I would like to show you this particular map. This is the map of BGP incidents based on grip data. As you can see in the US, Brazil, China, over the past year, they had lots of BGP incidents. These could be various incidents related to MOS or sub-MOS, but in Central Asia, there isn't a great number of those. You must understand that even one small error, tiny error, may result in serious implications. So even if they had 2 or 3 incidents, still you need to take this seriously, to treat these incidents seriously. Now let's get down to the practical things. Let's take a look at the level of raw implementation in Central Asia and in the other countries in the neighborhood. We can see that in general we have some very good level of coverage at IPv4 addresses, IPv6 a lot less, but because IPv6 addresses, there is much more of those. So here I'd like to draw your attention to part 2, the United Arab Emirates. The IPv4, IPv6, they have the very good raw coverage. They progress really well in the implementation of IPv6 and RIPE NCC. Colleagues are actively working with regulators in this country. This is one of the outcomes of the very good engagement with the telecom operators in this country. Let me quickly go through. This is already the timeline. This is the timeline. Well, Uzbekistan, not just because this is my motherland, my home. Over the last year, there was an increase in coverage of raw. TPS covered their IPv4 addresses back in July. Uzbek Telecom did this. So I'd like to know that back in May of this year, our colleague of ours, he spoke at the meeting of the Council of Operators, RCC, that was held back in Tashkent. So basically, he spoke with this presentation on secure routing. And after this, we saw the serious increase, and hopefully it will continue. Next one is ROA coverage. In the other countries, we had the same situation, no change. Kyrgyzstan, Turkmenistan, good data. In Kazakhstan, unfortunately, RPKI is not implemented. Of course, I would like to know the reasons behind this. If you are an operator from Kazakhstan, please come to me, and I'd like to know more about this, because my colleagues and myself, we really care to learn more, because in some of the other areas, Kazakhstan is much more advanced. Now, this is a new thing, or last year we didn't speak about this, because the region is developing fast in the area of the electronic government, e-gov, digital community development. We'd like to take a look at how the government's infrastructure or government domains, how they are protected with ROA. And we use this certificate transparency. We use the security transparency logs to find these domains, but this is not a full list. It's really hard to find the list of the government domains, but out what we found, in the region, everything is well protected with the exception of Kazakhstan. But we see that percentage-wise, ROA is not really high in Kazakhstan. Next one, we are approaching the next step, which is ROE. Tell me how much time I've got left. Okay, next one is ROE. We saw the schedules, we updated them, and use ROV, this methodology that defines the level of the implementation of ROV.
And in order to visualize the situation, we have also used the AS hegemony. The colleague from RPKI has participated in this study. So this is the analysis of ROV in the system, demonstrating that this is autonomous system is important and that it plays a central role in the routing of this country. We see that Kazakhstan is a very diversified, but orange circles stand for the areas where ROV is not introduced. Green one actually stand for the existing ROV, but green ones are not local. These are foreign autonomous systems. I have some good news for 2024. So Elkat, as far as I know, in Kyrgyzstan began introducing ROV. Anyone from Elkat, and I hope that that's the case. And it is excellent that is happening that way. And also Megaline. I know that you are here, and they also, you attended CAPIF last year. And it's actually excellent news. It's a very positive news. Turkmenistan, has slightly different picture with the interconnectivity. However, Turkmen Telecom, and that's most importantly, Turkmen Telecom being the most important autonomous system in the country's interconnect, actually is ROV protected. And we see that Turkmen Telecom is slightly ahead of Uzbek Telecom, so maybe there is regional cooperation. We don't know. These visualizations is available online. You can scan the QR and then you can click on your own autonomous system. And we have also added the information about APNIC, about the clientele, about the customer population, the population of the autonomous system. So you can see whether your autonomous system plays an important role in the country's interconnectedness. Well, I hope you scanned it and I hope everything works. And if it doesn't, just approach me and I'll give it a scan. So we of course say that some things, there are advancements are there, the progress is there, but actually measuring ROV is very, very difficult. My colleagues from the research department keep on debating on selecting the best tool to introduce ROV. And ROV is a good, convenient indicator, but the jumps and fluctuations happen continuously. One autonomous system can have a lot of upstreams, and some of them, introduce ROV, some of them don't, and that, of course, will affect the picture. And this is a very dynamic indicator. and it's difficult to measure. So now let me move on to the last part of my presentation, which is the IPv deployment in the region. So here we show the share of autonomous system, which reroute to IPv6 protocols. And since the last year, since we began demonstrating, actually, they're actually showing this report, we haven't seen any peaks. So in Central Asia, this level is 19%. In European Union, the level is about 40%. So we still have room to grow, and we are kind of behind, but I hope this number will grow. And this number also shows the preparedness of the networks and readiness of the networks to use the IPv6. However, when it comes to deployment of IPv6, according to content providers, and we're talking about Google, Facebook, Latvia, we see the leaders, Kazakhstan and Iran, leaders for all three sources. And Uzbekistan last year had 0, but this year that's already 11% for Google. Well, if you remember, IPv6 was officially launched in Uzbekistan, and probably this number was achieved thanks to that. And we do hope that this number will grow for all the region. We have colleagues from Iran who are quite advanced in this sense, and I'm sure that you can talk to them and kind of consult them as to how it is going. So, conclusions. RPKI is important, and the importance and significance of this technology is recognized not only by the tech people, but also by the governments. The U.S. Commission, US FCC, actually said that RPKI needs to be introduced, RPKI needs to be introduced. Also, the forum standard is DATSE of the Netherlands demands that the operators introduce RPKI, but if they don't, they have to justify non-introduction. So I think it is all up to you now. If you want to cover your RPKI, you can, yes, you can contact Alex Semeniaka. I'm sure he will be happy to help you. And waving at you over here, Alex Semeniaka. So, and what it means for Central Asia, if the state and the operators do something actively, then they can be the catalyst of the progress. So, the last, we know that IPv6 actually addresses are growing, the number of population is growing, the internet is growing. So we will have to introduce IPv6. It's like inevitable. Everything, the structure, the infrastructure, the modernization necessitates us to introduce IPv6. There are some links. Alex Semeniaka has translated the IPv6 protocols basics, kind of IPv6 101. He translated the whole course into Russian. So please go learn more. So here is a link. And this is my presentation. You can find it here. And so